The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to another Xylem webinar entitled SonTek RS5 Performance Down Under, which features our new SonTek RS5, the world's smallest ADCP, and our guest speaker today, Daniel Wagenaar. If this is the first time for you to join a webinar via GoToWebinar, just a couple of tips to share with you that will make the session a little more enjoyable for you. First, audio settings. On the right-hand side of your screen should be the GoToWebinar interface, which allows you to control your audio settings. And below that, we have a box for questions. We will be running a question and answer session at the end of Daniel's webinar today. We do invite you to type your question, any question that you'd like to ask Daniel at any time throughout today's webinar, and these questions will be addressed at the end of the presentation. And finally, at the bottom, you'll see another box entitled Chat. Please use this if you have any general questions about GoToWebinar, the content, or if you have any technical difficulties. Our marketing team is on hand to answer any questions you might have. All right, and now let's move into a quick introduction of our guest speaker today, Daniel Wagenaar. Most of you probably are already familiar with this gentleman. Highly knowledgeable. He has 2 bachelor degrees in science, one in water engineering, the other in geohydrology. He is our Xylem application specialist, and he began his hydrographic career in South Africa. He has over a whopping 32 years of experience, particularly in the development of acoustic Doppler measuring techniques and the enhancement of surface water methodology, quality assurance, and data management principles used in collection of acoustic Doppler data. So please sit back today and enjoy our webinar. Before I bring Daniel out, I'd just like to gauge our audience and why you've joined this webinar here today, and invite you to participate in our poll question, a very first poll question, which I'm launching right now. And on your screen, you should see a blue poll with the question, what's your main objective for stream flow gaugings and typical flow ranges that are targeted? So kindly move your mouse over the answer that you'd like to respond with and simply click with your mouse, and that will activate your poll question. Just give our audience a few seconds to respond. Looks like 60% of our audience have responded so far. We'll just give a few more seconds. All right, we thank everybody for their answers. Daniel, I'd like to invite you now. I'm sure everybody's curious to know the responses. It looks like 58% answered operational. Their main objective was operational, followed by 54% for research and 12% for regulatory functions. Is this what you had expected?
Yes, definitely. I think it's a broad application from various sectors, from seems to be irrigation to monitoring flows and natural channels. So definitely.
Terrific. Well, Daniel, yeah, let me pass the baton over to you, and please take it away.
Right. Thank you, Michael, for the introduction. Welcome, everyone, to the RS5 webinar. Today's topics, just briefly, why RS5, why was it developed, some of the issues that led to the development, the actual hardware and software discussions, and an outline of what was done by SonTek, beta testing performed during the development to get it to the final product, measurement results from tests we've done in Australia itself, what is currently further development or new development being done on RS5, existing ADCP use and why we think you should definitely see this as a solution. Haven't made the big leap, which is a big statement, more for users that haven't used acoustic Dopplers before, and then what is coming next with the development side. So if we look at why RS5 was developed or why another ADCP, the development was mostly driven by you, our customers, as well as the hydrographic community itself, to get an efficient ADCP solution for low to medium flow ranges. So to give you a little bit of a background, and it wasn't really intended to be part of this, the way that SonTek performed the development is we have a technical committee or team at SonTek that comprises of a number of hydrologists, hydrometers, hydrographers, and oceanographers that's in a team. They are spread across the world from the US to the UK, Australia, and so forth. And we look at areas and where we can improve the measurement efficiency, methodology, and basically the overall process of stream flow gauging. This is done in conjunction with all the feedback and recommendations we receive from customers and users, and that is then incorporated in the process itself. So you sit with a bunch of people or a group of people that's very skilled and extremely passionate about hydrometry. And we try to get the best out of a solution as far as possible. We also use the following, if you want to say, development cornerstones at SonTek. Enhance efficiency is probably at the top of the list. Improve measurement accuracy and techniques. And then finally, advanced software solutions to get the maximum out of the data collected. So what's the issues then? With the current products and solutions on the market, a really compact instrument or system was needed for quick deployment. Now, you don't want to spend time in the field assembling equipment, using tools like screwdrivers and Allen keys. It needs to be ready out of the box to perform the measurement. It needs to be integrated system. Customers doesn't want to incorporate third-party solution to get additional measurements such as depth measurements or GNSS reference tracks. A simple power supply, not providing multiple AA batteries or larger batteries to provide power supply, and then obviously easy to transport. A lot of the equipment needs to be carried to the site. It is difficult, it is expensive equipment that there is a risk of damaging during transport. So a quick and easy solution to put on your shoulder and off you go to do the measurement. Further improvements on measurements. We all know acoustic instruments do measure very accurately, but there are always improvements. In the case with especially focusing on the top surface cells in the channel itself. So the first couple of cells towards the water surface, try to improve the accuracy or measurement accuracy on that. In channels with very low velocity in deep channels, that creates a problem currently. Measurement sites with steep or vertical banks is a big limitation on acoustic Doppler instruments, especially because it's using a 4-beam solution, and then soft channel bed that or aquatic vegetation that absorbs the actual signal itself. If we look at the current GNS integrations, SBAS, it's a huge requirement for getting accurate GGA reference track. SBAS, unfortunately, is not available in Australia at this stage, also not in New Zealand, and some of the Asia Pacific countries. So having not the ability to use that correction process limits the use of GNS significantly, especially in Australia. Network RTK is a more modern type of solution, advanced network corrections that's provided to get very accurate RTK positioning. And then also the ability to incorporate any type of GNSS solution. A lot of customers use different brands and variations of GNS antennas or smart antennas, and the ability to incorporate those has become more and more, or the requirement has become more and more to do so. Advanced software solutions, having a data file or data format that's universal is critical nowadays. JSON is an open format that's used by thousands of users across the world, so it's not a hydrographic or hydrometric specific format, and there's significant amount of advantages using JSON. Extrapolation. Current ADCP solutions, irrespective of the brand, doesn't provide appropriate extrapolation tools in their software to perform velocity extrapolations on the profile. And that was one of the aspects that was directing a lot of users to use third-party solutions such as the USGS, Xtrap, and QREF. And then obviously incorporating the output of the data into user databases such as Aquarius, Heidster, and Whiskey is critical, because that improved the overall measurement process, increased the efficiency, and that is some aspect that needs to be automated at the end. So if we look at the actual hardware itself, as I mentioned, it's a compact system. The RS5 is approximately 50 millimeters in diameter. It's a completely integrated system with power supply inside the housing. It comprises of 3 megahertz frequency acoustic Doppler instrument with 4 beams with a Janus array arrangement and a vertical beam. So in total, it's 5 beams that was incorporated in the system. All 5 beams are 3 megahertz frequency. If we look at the water velocity component, the instrument has a profiling range of 0.1 to 6 meters. It has a velocity range of plus minus 5 meters a second, and a cell size from 2.5 to 30 centimeters, depending on the profiling technique that's used. Depth can be determined from either your bottom track or slanted beams or vertical beam. For the bottom track depth range, it's again at 0.1 to 6 meters depth, and the vertical beam goes slightly deeper from 0.1 to 6.5 meters in depth. The instrument itself has a purposely designed board that it's mounted on, called the Hydroboard 2 Micro, that also accommodates a mounting frame for a GNS antenna, as well as an extension for the Bluetooth radio communication. You will also see that the board has fins at the back to assist, especially during lower flow conditions, to align, or even during higher flow conditions, to align the platform better in the velocity direction. Communication is Bluetooth with a rated range around 100 meters. Power supply is a single lithium-ion battery. And then to complete the package, SonTek provided a backpack where you can place the board with the instrument inside, where you're able to transport the instrument to the water edge. So it's a complete system. You're able to transport or carry the equipment fairly safely to the measurement site without having additional pelican cases and loose components that needs to be transported. In addition, with the hardware, there was a couple of developments done on the actual acoustic Doppler profiling. The first is broadband. SonTek developed their own broadband solution, which is based on years of research and lessons learned in the industry. In addition to that, SonTek has also further improved their pulse-to-pulse coherent that was used in the River Surveyor M9, and that improvement has been implemented in RS5. And you could basically see the difference in the velocity profile measurements using broadband and pulse coherent in cooperation with incoherent. So basically the system will collect both data sets at the same time and then select the best data either from PC or broadband per sample. There's also another unique feature built into the system called stitching, where the instrument will combine cells that was measured using PC, pulse coherent, and cells that was measured using broadband. So you could have in a single sample, as you can see here under Aurora profiling, a sample will consist of both PC and broadband. So this is almost a similar technique that's used in oceanography, where they put bottom-mounted systems and it profiles up to the surface with different profiling techniques. This is an excellent tool for especially low flow measurements and shallow measurements, because it is improving the measurement accuracy of your measurement cells closer to the water surface, theoretically where your highest velocity occurs if your channel banks doesn't impact the velocity distribution. It's also a unique tool to use for methodologies that focus on surface velocity measurements, because you can really now focus on those top layers to get a very accurate surface velocity measurement. So if we look at the software, this is a complete new software package written from ground zero, if you want to call it like that. There's a couple of features, main features that was implemented. QC is a similar process or the same process that was implemented in River Surveyor Live. It's based on the USGS standards for assessment of moving boat measurements, and it's a very critical aspect for that process. The advantage of using QC is to ensure that while you are doing the measurement, that you are conforming to at least the USGS standards, and that if there's any significant warnings coming up, that you should rather identify the problem and resolve it, instead of just continue measuring on and collecting bad data. Beam switching is also a new feature. That's where we exclude data from a specific beam, and we will discuss this a bit later. Extrapolation, as I mentioned, is basically the flow or extrapolation calculations that the USGS implemented in Xtrap. We've able to implement exactly the same calculations in RSQ. So instead of using extract from UHS, you can process all the information in RSQ as well. Subsection is just subdivide a transect into different components. We have added an export for FlowPack, which is the SonTek Index Velocity software solution. KML export is a nice feature similar to QREF, where you can actually export the track reference to Google Earth. Obviously, this will only work if you have GNSS data collected to reference to make a due reference. And then one of the key important things is that we ensured is that the QREF data itself is able to be processed, the RS5 RSQ data itself is able to be processed by QREF for in detailed review. So the actual software itself comprises of two components. One is moving boat and one is stationary. So it's the same software package comprising of both components. So you don't sit now with two different software packages that you have to upload on your computer. And another advantage is that because it's a single software package, we don't charge separately for stationary. So you basically get moving boat and stationary for free. And again, I want to highlight on JSON. JSON is a universal format. It has significant amount of advantages, especially for researchers and users that wants to evaluate the data in depth. It also has the advantage that because it's a universal format, you don't need specialist assistance from either SonTek or any person that has hydrometric experience. Any programmer that's working with JSON would be able to pull the data out and display it for you. Michael, poll question 2.
Sure. Thanks, Daniel. Poll question 2, just launching now. What is the minimum number of beams required for moving boat measurements? If you're concerned about whether or not your name is associated with your answer, please have no fear. This is a completely anonymous poll. So if you're not sure about the answer, give it a try. Nobody will be able to identify whether you answered correctly or not. Just give the audience a few seconds to respond. Okay, allow me to share the results. So it looks like the majority of our audience, 45%, responded with 3 beams. So 3 beams seems to be the most popular response, followed by 4, and finally 2. What is the correct answer, Daniel?
For moving boat measurements, the minimum number of beams required is 3. And the reason for that is you need 3 beams to perform bottom tracking and resolve the velocity components. So for each dimension, you need a beam. So if we look at either bottom tracking velocity measurements, bottom tracking or velocity measurements, both has a X, Y, and a Z component. So for each component, you require a beam.
Excellent. Thanks, Daniel. And I'll allow you to continue with your presentation.
So I'm just opening RSQ software for you to see. I'm not going to go into too much detail, but what I will show you is just quickly some of the key features. So under tools, there's a couple of options that you can use. Settings mostly is just display, views, and then units. So for example, your GPS units, you can either do decimal degrees or degrees, minutes, seconds. Network RTK, this is basically the page you complete. So you will have your caster host, caster port, username and password. And in this case, we're using all-day RTK in Australia. There's other providers in Australia as well, but this is the one that Xylem is using. And then basically you request the information from the provider. The important aspect here is that you will have to have internet connection to your laptop or tablet or whatever platform you're using to operate the software. So this is slightly different from smart antennas, where you enter this information into the smart antenna. In this case, you populate it into RSQ software, and if you have internet connection, the corrections will be streamed directly to your laptop into the software. So if we open a file, you will see there's two files. One without the edited and then the edited included. So this is very similar to Flow Tracker 2, where SonTek, we tried to keep the original data set as secure as possible. So any changes or edits made to it will be stored in a separate file. This is very good practice for data management and quality assurance. It also indicates or provides the auditor of the data that changes were made to the actual measurement. So if we open the edited one, you will see that this looks very similar to River Surveyor Live. You have your reference track plot, your velocity profile plot at the bottom, a couple of time series plots at the top. On the left side here, is the sample table. So this table at the left is updated for every sample. And then your SNR plot here at the bottom. So it's very similar to River Surveyor with your transects at the top. If you want to show your QC window, just press Control Q and it will show there. Summary table is Control S. So all operations are very similar, so it would be very easy for you to step in, open a software, perform the measurement, and continue onwards with very little assistance. A couple of other settings that's of important is beam switching. So this is where you tell the software, if I select Add, I will tell the software, beam 1, can you please exclude samples 1 to 50? And that is the samples that was affected by a vertical bank or steep slope. And then the software will use for those samples only a 3 beam solution, not a 4. Another one is the extract method. Again, it's based on extract from the USGS, so the actual computer code is exactly the same. And as you can see there, it also looks very similar. So it's a very, very handy tool, especially for organizations and users that doesn't follow the USGS by heart. So this is a much better approach than just typing in a coefficient, because now you can physically see the slope of the plot. And see if it makes sense with regard to the data that was collected. If you are following the USGS protocol, then this won't really have an impact on your operations. We still have the option where you can export all the data in MATLAB for QREF to process. So that process is still intact and won't affect your operations. A couple of other aspects, Flowpack export and a KML export. Another thing that you probably should be aware of is that when you perform a measurement, the software closes off the file. So it's a single file that contains all the transects, compass calibration, system test, and so forth. If you want to import a separate transect into that file, that is feasible. So, for example, in this case, we only had 4 transects in a loop file. If I want to import an additional file, that is possible as well. So let's close the application now. So beta testing. I'm not sure if you had a chance to look at the webinars and papers provided by SonTek, but yeah, there was significant testing done across the world and various different channel conditions and sites. In Australia, we've done the same. This photograph here shows a measurement done in the Hunter River that is tidal impacted. So you have sediment deposition, soft sediment deposition in the channel itself, which was a great test bed or area to verify bottom tracking. We mainly focused shallow sections with clear water to determine the impact that on the velocity measurements, especially for very shallow areas, deep sections with slow velocities, all aspects that has impacted previous ADCP solutions, flood conditions with moving bed impacts, and then, as I said, tidal impacted areas. And the range of testing varied as well, from natural channels, irrigation, stormwater. We've done tests in Lake Macquarie, which is a saltwater lake, inland saltwater lake, as well as tests at KICT facility in South Korea. So it's definitely a wide range of testing, and I highly recommend that you have a look at the webinar SonTek provided. So if we look at the measurement results from the test done in Australia, obviously the first areas, or one of the first areas we've done, was verifying the operations in irrigation channels. Because it's such a small and portable system, irrigation channels fit very well in the application of this instrument. And you can see that the comparison between RS5 and M9 compares very well. Coefficient of variance, the Qs are very, very close. But there's one obvious thing that you notice here, is that the velocity distribution that's provided by RS5 is much more well-defined than with the M9. And that's because of the broadband and pulse coherent combination and interaction between each other, which provides you a much higher definition than incoherent, which is a bit more coarser, more focused towards deeper, faster channels. I'm not sure if you can notice there, but this tagline design was set up by Murrumbidgee Irrigation. It's shaped in a triangle, and it allows the operator to stand next to the post and move the instrument instead of bending over to reposition the instrument. There's also a flexible mat, if you can see there, that's connected between the board and the tagline, and that reduces lateral movement and improves accuracy of the measurement. If we go to the next site, this channel consists of extremely low velocities. It was also wind impacted. That's one of those sites that you probably never wish to get on your plate, because whatever you're going to do, the results is not going to come out very good. There's a large pool downstream. The velocities, as I said, is extremely slow. There was a rock outcrop on the upstream side, and you can see this was in this area. So the velocity distribution was all over the place, but the whole purpose of this measurement was to identify and verify the velocity measurements of the instrument itself, as well as bottom tracking over uneven channel bed. Flat and natural channel. Most organizations have a range of instruments from low frequency to high frequencies. With the M9, which is advantages because you do sit with both incorporated in the same system. Organizations tend to have one or two different instruments to take with, especially during a flood event, because of very sediment loads, bed movement, and velocities. So in this case, it was a measurement in a natural channel. The RS5 comparison against the River Pro was excellent, actually, for this site. And I was a bit surprised in the beginning, mainly because it was a flood event, and you will see that the maximum velocities was around 2 meters a second, high sediment loads, moving bed at the bottom, and there was, you can also look at the sediment deposition on the side, on the bank, on the access road there. But at the end, the results turned out very well, and this was actually right at the beginning of the testing phase of RS5. Michael, next poll question.
Excellent. Okay, Daniel, our next poll question is, what key measurement components of moving boat is dependent on accurate compass calibration and operation? Is it bottom tracking, GNSS track reference, XYZ coordinate system, or loop moving bed test? Again, this is completely anonymous, so have no fear of your name being associated with your answer. Please take a guess, an educated guess. About 50% of our audience has voted now. We'll just give a few more seconds. All right, it looks like most of our audience has responded. So allow me to share the results. It looks like the most popular response was GNSS track reference, followed by bottom tracking. Daniel, what do you have to say about this?
GNSS track reference is correct. The reason why we need an accurate compass calibration and operation is that compass measures magnetic north and GNSS measures true north. And we need to get both in the same reference. So we do use a magnetic declination to adjust the magnetic north, and for that we need an accurate compass. Otherwise, any impact on a compass will have an impact on the final result. It's also important to understand that the GNSS reference is used for the magnitude for the boat direction and speed and direction, where the compass is associated with the velocity measurements. And we have to get the velocity measurements and the boat speed and direction in the same reference. The second one that's also important is the loop method, moving bed loop method. Is also highly dependent on accurate compass calibration operation, and they are pass and fail criteria that's built into the method. So if the heading back and forth exceeds a certain degrees, it will fail the compass the actual loop method. So those two are the the two methods that's highly dependent on accurate compass calibration.
Great, thanks for that, Daniel.
So if we look at the next measurement or test results was also during a flood event. There was a number of M9s at different locations, a Rio Pro and RS5. This is basically just a summary of the results. I think the M9 measurements is probably an average of 3 or 4 systems. But you can also see the velocity distribution from the RS5. It looks more defined than with River Surveyor, although the two measurement sections are not at the same position. You will also notice that RS5 was, the boat speed was a bit quicker than the M9 measurement because each of these rectangles represent one sample and a sample is a second. So, you know, the faster you travel, the larger that block becomes. Part of the in-depth testing was ensuring that bottom tracking is accurate, because bottom tracking is one of the key aspects of moving boat. A lot of users does not use GNSS systems, and a lot of times you don't need GNSS system. If bottom tracking is still the most accurate method for moving boat, because you don't need an external reference, and the external reference can always introduce additional errors. And bottom tracking is not dependent on accurate compass calibration. So in this case, we've verified the bottom tracking in a channel with a soft bed, and there was organic matter lying on the floor as well. And organic matter or aquatic vegetation and soft channel bed tends to absorb the signal, which would result in invalid bottom tracking. But in this case, RS5 performed fairly well. There was areas at the edge, but that was because it was too shallow. It also shows you a magnetic error plot that was recorded, and it works exactly the same principle as River Surveyor Live, where you have internal compass. So we measured a magnetic field, we did the compass calibration, and we measured a magnetic field for every second the instrument moves along. And based on that, we can calculate the percentage difference between the compass calibration and as you perform the measurement. So in this case, we plotted the influence of the steel pipe, and there's a steel structure there where the IQ is mounted on. So this whole trend here is based on that influence, similar to what the River Surveyor Live and River Surveyor M9 has. New development. We're currently reviewing the SonTek RTK solution, and that was just one test to verify and to see how bottom tracking compares to the actual RTK solution. So over 189 meters, there was plus minus half a meter difference. I'm fairly confident with the RTK solution currently. It's able to get a RTK lock extremely quickly. And as we continue with the tests and development, we will keep users up to date if there's any interest for the RTK solution. A network RTK is also being verified currently. Again, it's a subscription service. There's a couple in Australia, of which one is all-day RTK. They're not cheap. It's about $750 a quarter to get a subscription. However, you don't need a second receiver or GNSS antenna. You only need a single one, and you could basically get RTK corrections with a single receiver and the subscriptions. So in a lot of cases, you probably don't need subscription for the full year, and you will only focus during flood events or rainy seasons. So that could be that you only have to activate the signal for 3 months. So that's all depending on your operational requirements, but that is also one solution. I think that's the one thing that SonTek was trying to achieve with GNS is to make as much possible solutions available to customers as feasible because of the complexity of GNS across the globe. Because the number of satellites available across the globe, GNSS corrections and all that varies significantly across the world. There is a difficult aspect to provide or solution to provide for. Stationary measurement, as I mentioned, RSQ will have two components, moving boat and stationary. We're currently performing tests on stationary, and as I said, stationary will be free of charge, included in the software. And if I'm not mistaken, we are looking at a release date of approximately the middle of the year, May, June, in that vicinity. The results we've got to this far is very good, very close to the moving boat measurements, and the latest ISO uncertainty calculations is already incorporated, as well as the USGS method, similar to Flow Tracker 2. So we've ensured that the development incorporates the latest international standards. Michael, next poll question.
Sure, Daniel. Next poll question is now on the screen. What is the purpose of a tagline azimuth during stationary measurements? Is it to calculate the flow, calculate the speed, or calculate the normal velocity to the tagline? Just give a few more seconds for the audience to respond. The responses seem to be fairly unanimous. All right, allow me to share the results. So it looks like the majority of our audience responded with calculate the normal velocity to the tagline. This was followed by calculate the flow, and no one responded with calculate the speed. So Daniel, what is the correct answer to this question?
The correct answer is to project or calculate the normalized velocity towards the tagline azimuth. So it's a tagline azimuth is a imaginary line across a channel perpendicular to the main flow direction, and the velocity components are normalized towards the tagline for the final flow calculation.
All right, terrific. Thanks for sharing that with us.
So if we are existing ADCP user, why do you need RS5? I think the first one is the unique broadband solution that SonTek implemented. And that basically will resolve areas where especially pulse coherent exceeds its depth range, as well as velocity range. And especially measurement sites where the minimum specified velocity is below the ICE incoherent methods. So in those cases, you can see in this case, the velocity was below the incoherent minimum specified velocity, where broadband and pulse coherent combined improved the measurement results significantly. So that is one advantage of the SonTek broadband solution. Profiling technique stitching, improve the measurement accuracy on the cells towards the surface or water surface. And as I mentioned previously, this is a fairly huge development because that's where your highest velocity occurs. So if the highest velocity is within pulse coherent range, you will definitely see improved accuracy in those measurements. This is also a fantastic way of applying this instrument where surface water techniques are being investigated or applied, such as radar and STIV and those methods, is where you can use this device to get a very accurate surface velocity to compare that with different techniques. Power supply, it's probably one of the biggest things, I think. Although it sounds like a simple solution and a simple topic, it does create headaches in the field where you have systems with 8 to 16 different AA batteries, and you have to unscrew lids and with screwdrivers or spanners, and that just creates problems and frustration in the field, especially if the weather conditions are not suited for that. So ease of access is fairly quickly. It's one cap that needs to be removed. It's a single lithium battery, and it's basically a lifespan of about 7 hours, which of continuous measurement. And that makes a big impact, because you can just imagine for yourself that 7 hours of battery life will cover your entire day of measurements. SonTek also provide a second battery as a backup, but also chargers that you can use in your car or truck to recharge if necessary. Bluetooth, simple solution. It's rated to 100 meters by SonTek. I've done a number of measurements of 140 meters plus, where I still was able to obtain good signal and was able to complete a measurement. I think the important thing was that my laptop that I was using was about 1.2 meters or 1 meter from the ground, so I wasn't sitting on the ground. So the higher you are from the water surface with your operating platform, the better, and that will just improve signal. Open surface water has the biggest impact on radio signals. So the further you away from that, the better. In this case, was one of my test sites close to Newcastle in the Hunter River, and I was able to get 250 meters before the software basically lost communication. So as I said, SonTek is fixed on 100 meters rated. We also believe that 100 meters is sufficient for this application at most monitoring sites, especially during low and medium flows. Small housing. It is extremely small housing, 50 millimeters in diameter, and the ability to incorporate 5 transducers in such a small housing is definitely a great feat. It's something to be seen. It is easy to transport and incorporate in existing platforms. You can mount this on RQ-Pod or a larger platform, and you can either acquire a foam insert or you can make your own. I've just, these foam dumbbells you use for swimming training, just use that in a bread knife and off you go. So it's fairly straightforward to install it in different boards. GNSS solution, I think, is one of the biggest advantages. SonTek provide the geode, which is a very simple, compact system. It has the ability it has its own iPhone app, which you can collect data on your phone if it's needed. It can also, on its own, access network RTK. But for the fact that Australia and New Zealand doesn't receive SBAS signals, the best you will get out of the geoid is using the V2G data string. GGA will still not be sufficient accuracy because we don't have external corrections. You can use the duate with network RTK. So if you enter the details in RSQ software, using network RTK, you will be able to get RTK quality data for fixed subscription per quarter. So just take that into account. But that is feasible. SonTek is working on its RTK solution, as mentioned previously, and that's to be released later this year. And then use the GNSS solution. Xylem Water Solutions Australia promotes the Hemisphere S321 and the S631 smart antennas, which is high-grade survey antennas. You can use it for bathymetry, hydrographic surveys, topographic land surveys, and those systems can be integrated with RS5 as well as any other user solution. So the only thing we need is that the instrument needs to output NMEA sentences at a certain frequency, and a special cable will have to be manufactured, which we already do for clients. So incorporating that, which we already do for clients for River Survey M9. So to incorporate this for RS5 should not be a problem. Beam switching, I think of all the years that I've been involved with SonTek, is probably this is the biggest headache for most customers, is the fact that acoustic Doppler or ADCPs currently on the market cannot accommodate channels with steep banks or vertical banks, and that is because one of the beams are impacted by the bank itself. Now, if you understand the principles associated with ADCPs, the depth of profiling that we do, velocity profiling, is based on the shallowest beam. So I'm going to say it again. The depth of velocity profiling is based on the shallowest beam that's measured. And the reason for that is the velocity components X, Y, and Z needs to be resolved for each cell on all four beams. So as you move down towards the bottom, if one of the beams doesn't have cells left, it can't extend past that. So if you look at this graphic here, you will see in the middle, the instrument was able to profile relatively close to the bottom. As you move towards the edge, and this is a vertical bank, you'll see it creates this trapezoidal shape, and that's because the one beam is getting shallower and shallower and shallower, so it's limiting the velocity profiling. So with beam switching, we basically tell the software, don't use data sets from sample 1 to 30. So we can't tell the software to switch off the beam. We're still collecting the data, but we, in the software, indicate don't use those samples for that specific beam, and then we're using a free beam solution. All right, so that's very important for moving boat. In the past, you had to be 50% of the water depth away from the channel or from the bank, which is a lot, especially if you measure at sites that's 4 to 6 meters deep. Then you are losing a fair chunk of the actual measurement, overall measurement. Xtrap, again, UCS solution that is incorporated. This is highly beneficial for organizations and users that don't follow the USGS by heart. But apart from, and it will give you a much more accurate estimation of the velocity profile. Subsection is basically just subdivide the transect into different components based on sample numbers, so that you can exclude certain portions depending on what you need the data for. And then the ability to open River Surveyor measurements, basically by pressing Shift Control and then the open button on the software will allow you to open RSV live measurement files, and you will now be able to save it in a JSON format. So that is you'll be able to edit the data in RSQ and save it in a JSON format. So that's an important aspect that you need to remember, because this will ensure that your data integrity and availability of raw data will continue for a long time forward. Unfortunately, you can't operate River Surveyor Live or River Surveyor, so you can't collect data with it, you can only process it. So, for those that haven't made the big leap, so what does that mean? So that's for our users that their main function is not performing discharge measurements or develop rating curves or operating and managing hydrographic or hydrometric monitoring sites. This is users that do more environmental assessment and stuff and doesn't have acoustic instrument or hasn't made that step yet. So if you're using a current meter, which there's nothing wrong with them, I've used them for years, or if you're using an orange down the river, that's one of the reasons. It's almost similar to a chippy's toolbox. You know, what's the most valued tool in his toolbox? Is it a skill saw or a hammer? This is the same here. RS5 extremely versatile, from very slow velocities and shallow conditions to, we've seen there 2 meters a second and up to 6 meters in water depth. So it is very versatile, and it is definitely suited for most applications. So what's coming up from SonTek's development? As I mentioned previously, stationary is being developed and tested, as well as SonTek's RTK solution and our network RTK option. There's 2 open spaces at the bottom that I'm extremely excited about, which I won't give any indication to, but it will definitely be, if all the checkboxes are ticked on this graph, it will have a significant impact on the application of the instrument, as well as improving the overall efficiency of discharge measurements in general. Michael, and last poll question.
Yes, thank you, Daniel. Last poll question for our audience. Just quickly, would you like an Xylem sales representative to contact you for more information about the RS5, flow monitoring, SonTek, anything related to today's webinar? Simply indicate here, and we will follow up or ask a specialist to contact you offline. And that brings us to the end of our webinar. We did promise a question and answer session, and we will honor that. We do realize that we've kind of gone over our time limit here, but we will continue for another 5 minutes or so to answer your questions. And we do invite you at this time, if you do have a question, simply type it out in the question box on your interface, on your GoToWebinar interface, and we will take those questions one by one.
Yeah, Michael, I'm not sure if you've mentioned it, but yeah, if we don't have time to respond to it now, we will respond to it in detail after the webinar in writing as well.
Certainly, yes, we can definitely take any questions you might have offline, and as Daniel said, we can address those after the webinar. Daniel, would you like to introduce the RS5 bundled package option?
Yes, so this is basically just a summary page that SonTek provided of the different options, 1, 2, 3, and 4. And as you can see, there's a couple of different features. You know, either just the instrument itself within a Pelican case. Second option would be the actual Autoboard 2 Micro and the custom backpack. Third option is just the instrument and a GNSS antenna. and fourth option would be everything included to date that was released. So for those users that have their own GNSS system and want to integrate it with RS5, you can either then opt for option 1 or 2, depending if you want the board or not. If you don't have a GNSS system but you need one, then options 3 and 4 is applicable. Again, with RSQ software, you will get both stationary and moving boat included.
Terrific. Thanks, Daniel. Could you take us to the final slide, please? Excellent. So a very informative webinar from Daniel Wagenaar, as always. And we now invite you to ask us any questions that you'd like answered. Simply, as I said before, type them out in the question box on your interface and we will address them, or we'll reach out to you after the webinar offline. There's also some email addresses that we've listed here for your convenience if you'd like to reach out to us offline. So we'll just give you a minute or two to load your questions in the box. One of the two most popular questions we get is, one, can I get a link to this video, to this recording? You certainly can. And the second question is, can I get a copy of this presentation in PDF format? And once again, you certainly can. How can you get a copy of the link and the PDF? We will be putting together a follow-up email in the next couple of days, which will include both, as well as some links to other related documentations that you might find valuable to you. So keep an eye out in your email box for that. It'll definitely be in your box before the end of the week. And also noted on this slide are 2 links where you yourself can browse through our online documentation, either via our SonTek brand site or our Xylem.com site. All right, Daniel, let's start with a few of the questions that we have queued up. The first one is, this individual tried to load RSQ on a Windows 10 tablet, but they kept getting a net framework error. Do you have any advice for them?
I think the best will be is if we prefer that to the SonTek tech support. It could be that there needs to be certain updates made on Windows 10 itself to accommodate for the software application.
Okay, so Windows tech support. What we'll do then is we do have your name and your email address, and offline we'll send you a contact information that will help support you with this issue. Next question. We are recently procuring ADCP for flow measurement. We were attending a small training on the use of ADCP, and we were told that it can only measure velocity of flow. But I wanted to know, can ADCP measure flow in the field or not?
ADCPs measure 2 components. One is the actual cross-section, and secondly, measure the velocity profile along the cross-section. So we're measuring 2 components. Flow or discharge is a calculated variable. So we don't physically measure discharge. We measure the velocity components in the channel and the cross-section. So as you drag or move the instrument from the left bank to the right bank, as that continues, we do continuous depth measurements as well as distant measurements, and then also velocity profile measurements every second. And from that, we determine a mean channel velocity and a cross-sectional area, and then we calculate discharge. So yes, you can determine the flow in natural or artificial channels with ADCP.
Yeah, and you touched on this next question briefly in your presentation, but I think it's beneficial to repeat this again. Can the ADCP enable to measure flow depth in still water? That is, could it be used to survey bathymetry?
Definitely. ADCP is just another form of acoustic Doppler instrument, but so is an echo sounder that is used for bathymetry surveys. All are based on the same principle, which transmit sound pulse in the water and wait for the reflection to come back. So with ADCPs, definitely yes. River Surveyor M9 from SonTek, which is a larger instrument than RS5, is used for bathymetry surveys. It's called Hydro Surveyor. So it has 9 beams in total, and you can get 5 individual depth measurements at any time. So in the case of RS5, it will definitely be feasible as well, although we haven't done any work on that. But with the SonTek RS Surveyor solution, you can do a complete bathymetry survey.
Thanks for that, Daniel. Let's move on to the next question. I am a new user and have been practicing. I often have an issue on the edges where the instrument won't proceed onto the transect, beam to shallow. How do I get past this?
It is a tendency by most users, and to be honest, I'm also guilty of that sometimes, is that you want to measure too much of the channel. And that could impact the accuracy of the overall measurement. It is very, very important that you start the edge measurement where you get a minimum of 2 cells. I would actually recommend that you go a bit deeper where you get a bit more than 2 cells. Because what the software does is it will collect velocity measurements at that specific location and then extrapolate that to the edge or edge to get the edge measurement. And if that's not done correctly or accurately enough, it will impact your entire measurement. The same with where you start the transect. If you have invalid cells or invalid depth, or insufficient cells, then that will impact your start of the transect as well. So I will always recommend to be careful of that. The QC box in both River Surveyor Live and RS5 provides you warnings when that happens. So the best recommendation is to move the instrument a bit deeper in the water until you get sufficient cells before you start the measurement.
Terrific. Thanks, Daniel. Next question. Can I use RS5 on my RQ pod?
Definitely. There is mounts available. I've seen customers made 3D printed mounts for RS5 into the RQ pod board. As I said, I went to a sports shop. You buy these soft foam dumbbells that you use in swimming pools, and I basically took a bread knife, cut it smaller, and put it into RQ pod. So you basically just need a foam insert to reduce the space in the dowel that was designed for the M9. So it's definitely feasible, yes.
And our last question, how do I use an RS5 on a River Surveyor riverboat?
On a River Surveyor riverboat, I assume that's referencing to the harder board 2, which is the bigger board of the range. So SonTek has 3 sizes, the harder board 2, the mini, and the micro. The micro is the RS5 design. And again, same principle as with RQ pod. You need a foam insert at the least to mount the instrument into the existing wet well of the board. So you can do it yourself. It's not complicated. You just need to make sure that everything fits in very tightly so that the instrument doesn't fall out while you're measuring. Or you can purchase a foam insert from SonTek.
Terrific. Thanks again, Daniel. Well, that wraps up the questions for this webinar and for the webinar in its entirety. Daniel, thank you so much for your time. And to our audience, thank you so much for attending. Once again, please keep an eye out in your email box for a follow-up email, which will include a link to a copy of the PDF version of this presentation, as well as a link to the video and other document resources that you might find of interest. And again, if you have any other questions for Daniel or our regional sales specialist, be sure to reach out to us using the email addresses that are displayed on your screen. Daniel, would you like to close up the webinar?
Yeah, I just want to say, thank you very much for everybody that's attended. This is one of the favorite projects we've been involved in. So feel free to forward any questions you may have, and if you need any technical assistance with the hardware or data review, please feel free to contact me.
Excellent. Thanks, Daniel. Thank you, everybody, and stay safe out there. Goodbye.
Bye.